All right, now I'm going to look at the same series, 1 over n to the p, but now p is going to be less than 1 instead of greater than 1. All right, well, if you'll notice, all the work I did up here is still true. So I'm going to let f of x be 1 over x to the p, but now I'm going to assume p is less than 1. Well, what I get is x to the 1 minus p over 1 minus p again. I evaluated between 1 and infinity. I again come up with b to the 1 minus p over 1 minus p. Subtract 1 over 1 minus p, but now what's true? P is less than 1. Well, if p is less than 1, then 1 minus p is greater than 0. And that's the key. Because if 1 minus p is greater than 0, then this is a positive power. And if b tends to infinity, b to a positive power tends to infinity. And what happens to this limit? It goes to infinity. What does that mean? This integral diverges. And the integral test says that if this integral diverges, then this series, 1 over n to the p, where in this case p is less than 1, also does what? Diverges. Okay, and that gives us both this example here and this example here. We combine those as well as what happens when p is 1 to give you this following result for p series. Whenever I look at the summation n running from 1 to p of 1 over n to the p, if p is greater than 1, it converges. But if p is less than or equal to 1, it diverges. So now I think I'm going to leave it at that. And in the next video, we're going to do a few examples.